Assalamualaikum, my name is Anis. We explain about the question 1a. So question 1a is given an expression y equal to x squared plus bx. Obtain an ordinary equation from the expression by eliminating the constant. So for the answer is we get x squared double prime minus 2x prime plus 2y equal to 0. To solve question 1a, we will symbols a, b, s, dy2, dy1, and then the given equation. Second, for the step is we need to first differentiate, and then we will get b plus 2ax, and then for the second differentiate, we will get 2a, and we will solve the equation for a, and then substitute the value of a, and then we will solve the equation for differentiate. First differentiate, and then we will get the substitute of a and substitute of b. Next, after we simplify, we will get the final answer, which is similar with the calculation. For the question 1b, show that y equal to x power of 3 divided by 2 plus c divided by x is the solution for the differential equation dy over dx equal to 2x squared minus y over x. For the manual calculation, we get the answer is y equal to x power of 3 divided by 2 plus c over x. To solve the question 1b, use symbol ys and then differentiate y. After that, we will get differentiate y x, and we will use this equation, which is differentiate yx equal to 2x power square minus y over x, and the answer is c1 over x plus x power of 3 over 2. This is same with the calculation. For question 1c, we need to find for y prime plus x square y equal to 0 by using two methods, which is first method is separation of variable. For separation variable, we get c exponent negative x power of 3 over 3, and for the second method is power series without using recurrence relations. For the answer is we get y equal to a0 exponent negative x power of 3 divided by 3. For question C, there are two methods to solve the question, which is separation of variable and power series method. For the separation of variable, we use symbol ys, and ODE1 differentiate yx plus yx squared equal to 0, and the answer is c1 exponent negative x power of 3 divided by 3. And for the power series method, it's also the same, only change for this, which is dissolve ODE2 expansion point until 5. So find power series around 10 till 5%, and the answer we get is this, which is quite similar with the calculation.
Hi, Assalamualaikum. My name is Mohamad Amirul. My matrix number is CE210027, and I'm from group 4 for ordinary differential equation section 5. Okay, now I will explain for the question 2a, which is determine the solution of y double prime minus y prime equals to exponent 2x minus x plus sine x using the method of anatomic coefficient. So you can see this is the manual calculation for question 2a. For the step 1 is yc homogeneous equation, and we get yc c1 plus c2 exponent x. And then for the step 2, which there is yp, particular part by part. And first yp1 we get exponent 2x per 2, and then yp2 we get ax power of 2 plus bx. So we can see yp2 is equal to, in bracket, 1 over 2x plus 1, x equals to x power of 2 per x plus x, and then the yp3 is equal to negative 1 over 2 sin x plus 1 over 2 cos x. So the next step is step 3, add all the yp. So yp is equal to yp1 plus yp2 plus yp3. So yp is equal to exponent 2x over 2 plus x power of 2 over 2 plus x minus 1 over 2 sin x plus 1 over 2 cos x. So the general solution is y equals to yc plus yp. So we get y equal to c1 plus c2 exponent x plus e exponent to x over 2 plus x power of 2 over 2 plus x negative 1 over 2 sin x plus 1 over 2 cos x. So next I will show the simulation. So this is the simulation for question 2a. So for the first we get the m is equal to m1 is equal to 0 and m2 is equal to 1. So you can see the simulation, we get the last answer is same with the manual calculation. So that's all from me, the question 2a. Thank you. Assalamualaikum. Okay, next I will present for the question 2b, which is show that using operation of parameter method will produce the same solution as question 2a. So the manual calculation is for the question y double prime minus y prime equals to exponent to x negative x plus sin x. Okay, first we determine a is equal to 1 and function of x equal to exponent to x negative x plus sin x. So yc is equal to y1 plus y2. For the step 1 is homogeneous part. Double prime equals to y prime equal to 0. So m1 is equal to 0, m2 is equal to 1. For the step 2 is wrong scan is y1, y1 prime, y2 and y2 prime. So 1 0 exponent x. So wrong scan is equal to exponent x. And then for the step 3 we want to find u and v. So for the u is negative exponent to x over 2 plus x power of 2 over 2 plus cos x. And then for the v is v equal to exponent to x plus 1 minus 1 over 2 sin x minus 1 over 2 cos x. So for the step 4 is addition value of u and v into equation y equal to u plus v. So and then for the yp is exponent to x over 2 plus x power of 2 over 2 plus exponent x plus x negative 1 over 2 sin x plus 1 over 2 cos x. So the general solution is y equals to c1 plus c2 exponent x plus e exponent to x over 2 plus x power of 2 over 2 plus exponent x plus x minus 1 over 2 sin x plus 1 over 2 cos x. So for the simulation is, first we determine a b x dy1 dy2 w and function of x. So y1 is 1, y2 is exponent x, and then dy1 is equal to 0, dy2 is equal to exponent x. So the raw scan is 1 0 exponent x. So scan is exponent x, a is equal to 1. So if you can see y is equal to a negative exponent to x over 2 plus cos x plus exponent x, b plus exponent negative x plus exponent x plus x exponent negative x minus exponent negative x cos x over 2 minus exponent negative x sin x over 2 plus x power of 2 over 2. So for the last general solution is a plus x plus exponent 2x over 2 plus cos x minus sin x over 2 plus b exponent x plus x power of 2 over 2 plus 1. So that's all from me for the question 2. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad HAZIQ OSMAN, CE2100C. I will explain for the question 3. For the question 3 is given a non-homogeneous system of the first order linear differential equation as shown below, which is y1 equal to negative 10y1 plus 10yt plus 5, and for the y2 is negative 20 over 3 y1 plus 98 over 15 y2 plus 10 over 3. And for the question 3A is to evaluate the general equation of the homogeneous system, and question 3B is to determine the particular integral for the non-homogeneous system, and question 3C is to formulate the general solution for the non-homogeneous system, and question 3D is to calculate the particular solution for y1x and y2x with y0 equal to 1, -1. Okay, this is the simulation part for the question 3A. So for firstly, we have to determine the SYS underscore DE, which is d over dt I1 t equal to negative 10 I1 t plus 10 I2 t plus 5 and d over dt I2 t equal to negative 20 I1 t plus 98 over 15 I2 t plus 10 over 3. So this is the output that we get. The output is SYS underscore DE equal to d over dt I1 t equal to negative 10 I1 t plus 10 I2 t plus 5, and d over dt I2 t equal to negative 20 I1 t over 3 plus 98 I2 t over 15 plus 10 over 3. So this is the matrix. The matrix that we get is, the value of the matrix that we get is negative 10, negative 20 over 3, 10, 98 over 15. And for the caret polynomial, we get is lambda power of 2 plus 52 over 15 lambda plus 4 over 3. And for the engineer level A, equal to negative 26 over 15 plus 2 square root 94 over 15, and negative 26 over 15 minus 2 square root 94 over 15. Also, the next part is to engineer vector v1 and v2, and for the v1 that we get is s1 and y1, and v2 is s2 and y2. And this is the matrix part. Also, the next part is to equation first engineer vector e1. For the equation 1 that we get is negative 124 over 15 minus 2 square root 94 over 15 x1 plus 10 y1, and negative 20 x1 over 3 plus 124 over 15 minus 2 square root 94 over 15 and y1. So this is the output for the equation 1. And for the y1, we have to solve y1 and x1 simultaneously, which is for the y1 we get 62 plus square root 94 x1 equal to 75. Also for the s1, we get the value of the s1 is s1 equal to 1. And for the v1, we have to determine the matrix, which is for the v1 we get is 1, 62 over 75 plus square root 94 over 75. The next part is equation second in the vector e2, which is determine the value of the equation 2. Is also same for the equation 1 but have a different, which is we get negative 124 over 15 plus 2 square root 94 over 15 x2 plus 10 y2, and negative 20 x2 over 3 plus 124 15 plus 2 square root 94 over 15 y2. Also for the y2, we have to solve y1 and x1 simultaneously, which is y2 equal to negative 62 plus square root 94 x2 equals to 75. Also we have to determine the value of s2, which is we get is s2 equal to 1. And for the v2, this is the matrix part for the v2, which is we get 1, 62 over 75 negative and minus square root 94 over 75. Also the last part for the question 3a, this is the answer that we get, which is general solution homogeneous system. So this is the value of the IH. They are the same answer that we get from the manual calculation. So I determined that this is the correct answer. And for the question 3b, IP equal to matrix for the IP. For the IP equal to U1 and U2, and this is the next part, which is U1 and U2. for the equation particular, we get the value which is equal to 0 equal to negative 10 u1 plus 10 u2 plus 5, and 0 equal to negative 20 u1 over 3 plus 98 u2 over 15 plus 10 over 3. So the next is equation particular, which is this is the output that we get. Okay, and then the next part is solve equation particular, which is that we get for the u1 equal to 1 over 2 and u2 equal to 0. Also, we have to determine the particular integral of non-homogeneous. For the IP that we get is 1 over 2 and 0. Also, this is the correct answer that we get between the manual calculation and simulation. For the question 3C, formulate the general solution for the non-homogeneous system, which is I equal to IH plus IP. This part is to determine the general solution non-homogeneous. So this is the answer that we get. Also the correct answer that we get, which is between the manual calculation and the simulation part. Okay, for the question 3D is to calculate the particular solution for y1x and y2x with y0 equal to 1, negative 1. Also, we have to determine the value of the y1 and the y2. For the y1, we get the output is y1 equal to c1 plus c2 minus 1 over 2. And for the y2, this is the y2. For the output of y2, we get is 62 over 75 plus square root 94 over 75. For the c1, plus 62 over 75 minus square root 94 over 75 for the c2 and plus 1. And for the equation A equal to c1 plus c2 and plus 1 over 2 minus 1. So this is the output that we get, which is equation A equal to c1 plus c2 plus 1 over 2 minus 1. Equation A, c1 plus c2 plus 1 over 2 equal to 1 for the output for the equation A. And for the equation B, this is the equation B that we get, which is the output that we get is equation B equal to 62 over 75 plus square root 94 over 75 for the c1 and plus 62 over 75 minus square root 94 over 75 for the c2 equal to negative 1. And then the next part is solve the equation A and equation B. So this is the output that we get, which is c1 equal to 1 over 4 minus 53 square root 94 over 94, and for the c2 equal to 1 over 4 plus 53 square root 94 over 94. And the last part is the answer. Refer to the manual calculation. We assume that our answer is a correct between the simulation and the manual calculation. Okay, that's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad HAZBI OSMAN, CE 21002C. I will explain for the question 4A. The question 4A, they are given a differential equation y minus 8y prime plus 3y equal to ft, where the ft is a periodic function as shown in figure question 4A. So this is a figure for the question 4A. And for the question 4A, 1 Roman is to find the piecewise function of ft, and question 4A 2 Roman, find the Laplace transform ys of the differential equation with initial value when t equal to 0 and y equal to 1 and y prime equal to negative 2. So this is our question 4A 1 Roman. firstly r equal to 10, so the output is also r equal to 10, and l equal to 2, so l equal to 2, and vt equal to 2 exponent power of negative t minus 1 multiple h t minus 1. So this is the output that we get. And the next part is r multiple di over dt plus l differential power of 2 yt and t equal to vt. So this is the output that we get, which is 10 d over dt it plus 2 d over dt yt power of 2 minus equal to 2 exponent power of negative t minus 1 and multiple h t minus 1. So this is the output that we get. The next part is di over dt plus 5 it equal to exponent power of negative t minus 1 multiple h t minus 1. So this is the output that we get, which is d over dt it plus 5 it equal to exponent power of negative t minus 1 multiple h t minus 1. Okay, the next part is ODE 4 equal to d over dt it plus 5 it equal to exponent negative t equal t minus 1 multiple h t minus 1. So this is the output that we get. And then for the particular result, this is what we get for the output. And then the next is ODE 4 equal to d over dt it plus 5 it equal to exponent power of negative t minus 1 multiple h t minus 1. So this is the output that we get. And the next part is equation equal to Laplace ODE 4 t and s. Okay, this is the output, the answer. And the next part is equation equal to subs Laplace, which is equal to Laplace exponent. I'm sorry. Okay, the next part is equation subs Laplace it plus t plus s equal to is I0 equal to 0 and equation. So this is the output that we get, which is equation equal to is plus 5I equal to Laplace exponent power of negative t minus 1 multiple h t minus 1 t and s. The next part is f equal to piecewise, which is 0 less than or equal to t and less than 1 and t 1 less than equal to t less than 2 and 1. So this is the output. And for the graph, which is plot builder piecewise, and this is the output that we get. You can see that for the x1 axis, which is 0 until 2, and the x2 axis 0 to 1. So this is the graph that we get for the question. Okay, the next part is for question 4A to Roman. So firstly, we determine the SYMS, T, S, YT and I underscore LT. So this is all the input. This is all the input that we determine to get the output. Okay, firstly, f equal to piecewise, t larger than 0 and t less than 1, t and t larger than or equal to 1 and 1, the next fs Laplace fts multiply 1 over 1 negative exponent negative 2 multiply s. Okay, the next part is equation 1 equal to differential y t and 2 negative 1 multiply differential yt plus 3 multiply y equal to double equal to 0. Okay, the next is equation 1 lt equal to Laplace equation 1 t and s. And then equation 2 subs equation 1 lt y0 and 1. The next is equation 2 subs equation 2 subs differential yt t and 0 and negative 2. The next is equation 2 lt equal to subs equation 2 Laplace yt t s and I underscore lt. The next is equation lt equal to equation 2 lt vars equal to I underscore lt. The next is I underscore lt equal to solve equation lt and vars. Okay, this is the output that we get, which is f equal to piecewise t into interval 0 and 1 t 1 larger than or equal to t and 1. And this is the output for the fs, and also this is the output for the equation t, which is that we get is 3 multiply yt minus 8 multiply differential yt t plus differential yt t and equal to 0. And this is the output for the equation 1 lt, and this is the output for the equation 2. Also, this is the output for the equation 2, and this is the output for the equation 2 lt, which is that we get is 3 multiply I underscore lt minus s minus 8 multiply I underscore lt multiply s plus I underscore lt multiply s power of 2 plus 10 equal to 0. And this is the output for the equation lt 3 multiply I underscore lt minus s minus 8 multiply I underscore lt multiply s plus I underscore lt multiply s power of 2 plus 10 equal to 0. And this is the vars, the output of the vars, which is I equal to lt. Okay, the next part is the find the answer of the question for A to Roman, which is I underscore lt equal to s minus 10 over s power of 2 minus 8 multiply s plus 3. So the answer that we get from the simulation are similar to the manual calculation that we get. Okay, thank you, that's all. Okay, the next is question 4b, I Roman and 2 Roman. Refer to the question is a series LL circuit is shown in a figure Q4 question 4b where R equal to 10 ohm and L equal to 2 Henry. The source to the circuit is given as a Vt equal to 2 exponent power of negative t bracket t minus 1 multiply h bracket t minus 1. For the question for B1 Roma is by applying Kirchhoff law, show the circuit can be presented by the following equation, which is di dt over dt plus 5it equal to e power of negative t bracket t minus 1 multiple h t minus 1. For the question for B2 Roman is determine the current IT for the circuit using Laplace transform with initial condition I not equal to 0. So this is the coding that we make. Firstly, this is the output, this is the input that we use to produce the output. Firstly, sims t sit I underscore lt l r. Okay, the next is v equal to piecewise bracket t less than 0 and t less than 1, 0, t larger than 1, 2 multiply exponent bracket negative t multiply bracket t minus 1. The next is vs equal to Laplace bracket v, t and s. And for this part is to plot and a graph. And next v1 equal to 2 multiply exponent bracket negative t multiply t minus 1 multiply heavy side bracket t minus 1. The next is equation equal to L multiply differential IT plus R multiply I equal to V1, and the next is equation 1 LT equal to Laplace bracket equation T and S. The next is equation 1 LT equal to subs bracket equation 1 LT I not and 0. The next is equation 1 LT sub equals subs bracket equation 1 LT Laplace IT T and S bracket I underscore LT. The next is vars equal to I underscore LT. The next is I equal to LT. I underscore LT equal to solve equation 1 LT and vars. The next is equation 1 sol equal to I Laplace bracket I underscore LT S and T and semicolon. The next is I sol equal to subs bracket I1 sol bracket R and L and bracket 10 and 2. So this is the output that we get. First, V equal to piecewise bracket T less than 0, 0, 1 less than T and 2 multiply exponent bracket negative T multiply T minus 1. And this is the output for the Vs and output for the V1. Also, this is the output for the equation T. And then the next is equation 1 LT equal to R multiply Laplace IT T S minus L multiply I naught I 0 minus S multiply Laplace IT T S equal to 2 multiply exponent negative S multiply exponent negative 1 over bracket S plus 1 power of 2. The next is equation 1 LT R multiply Laplace IT T S plus L multiply S multiply Laplace IT T S equal to 2 multiply exponent negative bracket negative S multiply exponent bracket negative 1 over S plus 1 power of 2. Okay, the next is equation 1 LT I underscore LT multiply R plus I underscore LT multiply L multiply S equal to bracket 2 multiply exponent bracket negative S multiply exponent bracket negative 1 over S plus 1 power of 2. So this is to determine the input of vars equal to I underscore LT, and this is the last answer that we get before to the question. The last answer is ISO equal to 2 multiply Haverside bracket T negative 1 multiply exponent bracket negative 1 multiply exponent 5 minus 5 multiply T over 32 minus exponent bracket 1 minus T over 32 and plus bracket exponent 1 minus T multiply T minus 1 over 8. So refer to the output. All the output that we get, they are similar to the manual calculation that we make. And that's all. Thank you. And the last one is the graph that we get for the question 4B. This is the graph. This is the time is negative 5 until 5 and 0 until 0.25. This is the graph for the question.